I'm going to jump over here again, and we're going to get to macrocytic, okay? And with the macrocytic, it means that they're bigger than 100 femtoliters. Macrocytic. But also with macrocytic, remember that, again, you already told me, let's say, the main ones, and the main ones are folate deficiency and B12 deficiency. Those are the major ones you should know. But it gets more complicated with macrocytic, but not as too much. I mean, maybe it's simpler. But remember, macrocytic, it's a general term. It means I'm having bigger erythrocytes. And basically, you got two main divisions over here. And the one of them is that it could be poisoning of alcohol again, direct alcohol poisoning, or for example, myelodysplastic, anything. But over here, the cells are going to be only big, okay? Big and round. They're big and round, so they're macrocytic only. But then you have another type, and it again fulfills the macrocytic, that they're big, but there's one more thing to do, and you call them megaloblastic. So megaloblastic anemia, it's a subgroup of the macrocytic, okay? So you all call them macrocytic, but if you say megaloblastic, you're already telling someone, hey, there's something with folate or with B12, okay? And I'm going to jump to a clean paper and repeat it once again, that we got space to talk about it. So we're jumping to macrocytic anemias. And important thing over here, what we talked about is that over here, again, how it's going to be with reticulocytes, the production is decreased. So they're going to be decreased, but that's what you would expect, okay? And why are these cells big? Well, because they're not able to divide in the bone marrow as well, but they're pretty fine with production of hemoglobin. So they're producing hemoglobin more and more, but they are lazy in division, okay? And because there's problem with division, some of them lies. That's important. That's crucial. But they lies within the marrow. So you should remember a special term which is called intramedullary hemolysis. Okay, intramedullary hemolysis. Yeah. And by the way, what you're going to check in the blood to tell there's hemolysis, you're going to check LDH. Anytime you look for hemolysis, LDH is going to be big. Even the intravascular doesn't matter. LDH. Okay. What else going to be higher a bit, because it sort of gets out of the bone marrow? It's going to be unconjugated bilirubin, okay? And what's going to be decreased in this case, those are the reticulocytes. And this is crucial difference between hemolytic anemias. Get it? Because in hemolytic anemia, you're going to have also LDH increase. You're going to have also unconjugated bilirubin, but you're going to have also, not immediately, but in 2-3 days, increased percentage of reticulocytes. Okay? But sort of this simulates a bit intravascular or extravascular hemolysis, except the reticulocytes. They don't fit there. Okay? But with this also you can have some free iron in the blood. Can be a bit decreased because it just gets dissolved from the bone marrow. Okay? Yeah?
Sorry, can I ask a question?
Yeah.
Are you talking about megaloblastic
No.
anemias
Still,
in general now, or is
still macrocytic. I didn't divide it. I'm repeating what I said before. Okay.
okay? So this is
So
all
in general,
macrocytic.
I just wanted to
Yeah.
fill you the scheme before, and now we're getting deeper in macrocytic. And I have to now. I see the time, and I'm going to speed up. But guys, don't worry. You got the cold videos, and there's everything in detail. So just watch it later today, and you're gonna get it. I'm gonna go very fast now. Sorry for that. Anyways, so over here you're gonna divide it only onto pure macrocytic, and then you're gonna go for megaloblastic. And it's very easy to say the difference because you check the blood smear, and what you will see in terms of macrocytic, they're gonna be only big. They're gonna be rather round. And common cause, there could be something with liver and alcohol. Watch out, not with the liver, but alcohol have a direct effect on bone marrow. Okay, it's toxic not only to liver but also to bone marrow, remember? And so those are the causes if you see only round erythrocytes. But there's another thing you're going to look in the blood smear, and those are neutrophils. And then going to be totally normal over here. Neutrophils going to be normal. They're going to have like 2 segments. In contrast to megaloblastic, if you have not enough of, that's why we call it megaloblastic. If you don't have enough of B12 or folate, then you're going to have, first of all, big but oval, rather oval erythrocytes. Okay? And then you're going to have, that's crucial, polysegmented. Again, they're not able to divide so well in the bone marrow, so they are like older and they have more segments. So typically, if you do a blood smear and you see big erythrocytes, rather oval, but that doesn't have to be a super rule. But the super rule is if you check the cells next to them and they're neutrophils and they're polysegmented, it's megaloblastic anemia. And one more comment, very important one. Remember, B12 deficiency, in contrast to folate, has also neurological problems, which are very dangerous. So neurology, there could be parastasias, so there could be peripheral polyneuropathy or dementia, even dementia. And the problem is, if you substitute B12 deficiency with lots of folate, you can normalize totally the anemia. The metabolism is very similar. You will normalize the anemia, but you won't normalize the dementia. So always check for B12 levels, okay? And I don't have to tell you with B12, remember pernicious anemia and all these things. You got it on the video, okay? So you can check it on the video. But remember, polysegmented neutrophils, big erythrocytes, that means megaloblastic anemia. And it could be either inherited, okay, some special ones like Fanconi. But the thing you should really think of is B12 deficiency or folate. Okay? So, thanks for watching. And don't forget to subscribe and ring that bell. And as always, check the description below for supplementary questions and other materials.